Hello friends, in this new video we are going to study about Carnot cycle. So first let me draw the graph of the Carnot cycle, that is the PV curve or pressure volume curve. This is process 1 to 2. It is 2 to 3, then here comes 3 to 4 and 4 to 1. That will be 1, 2, 3 and 4. The process goes like this. Since it is a PV curve, you can see that these here heat is added, that is Q1, and from here heat is rejected, that is Q2, and these two processes are the adiabatic processes. Now let me explain all the processes by writing them along. So process 1 to 2 is reversible isothermal process. Process 2 to 3 is reversible adiabatic process. Process 3 to 4 is again reversible isothermal process, and similarly process 4 to 1 is reversible adiabatic process. So what does this process do? We know that this is a gas power cycle. Hence, the reversible isothermal process, heat is transferred from high to low reservoirs, that is high temperature to low temperature reservoirs. So you can see from process 1 to 2, heat is transferred isothermally, that is the temperature remains constant. So here in this process 1 to 2, you can say dt equal to 0 because temperature remains constant. Now the process 2 to 3 is adiabatic process, that is temperature of working fluid decreases from high flow to low flow. So this process is adiabatic process, and from this process you can write PV to the power gamma is constant. Again in 3 to 4 the same process of 1 to 2 repeats, but you can see in reverse direction. So in this process heat is transferred to low temperature sink. So heat is transferred to low temperature sink, and it is also an isothermal process, so dt equal to 0. And last but not the least, process 4 to 1 is also a reversible adiabatic process, which implies that PV to the power gamma will be constant again. Now I think you have all understood the Carnot cycle and the processes that goes on. Now let's move on to the efficiency of Carnot cycle. So now let us derive the formula for efficiency of Carnot cycle. Remember, this is a very important topic from examination point of view. So we can see that in process 1 to 2 it is isothermal. Hence Q1 from 2 will be equal to work done in 1 to 2. That is equal to, we can write from V1 to V2 integration of PdV. Why I have written PdV? That you may see in the previous videos. So it can be written as equal to M into R into T1, that is temperature at 1, into ln V2 by V1. And we can see Q2, since it is an adiabatic process 2 to 3, so Q 2 to 3 will be 0. That is, in adiabatic process, heat transfer is 0. So Q2 to 3 will be 0. Similarly, Q4 to 1 will also be 0 because this is also an adiabatic process. Now Q3 to 4 will be equal to minus of W3 to 4, as because it is in the opposite direction. So we can write minus integration from V3 to V4, similar as before, P dV, that is equal to minus M R T ln V4 by V3. We know that the formula for efficiency that can be denoted as eta Carnot is equal to Q1 to 2 minus Q3 to 4 by Q1 to 2, which becomes, on equating, 1 minus Q3 to 4 by Q1 to 2, which, on further putting the values that I have previously derived, it becomes 1 minus M into R into T2 into ln V2, it will be V4 by V3 by M into R into T1 into ln into V2 by V1. Now, considering reversible and adiabatic process, we know PV to the power gamma equal to constant, as we all know from before. So we can write T2 by T1 is equal to V2 by V3 whole to the power gamma minus 1, which implies that T2 by T1 is equal to V1 by V4 whole to the power gamma minus 1. Therefore, V2 by V3 is equal to V1 by V4, which implies that V4 by V3 is equal to V1 by V2. Hence, by replacing these values, we can write efficiency of Carnot cycle, that is eta Carnot, is equal to 1 minus T2 by T1. So, this is the formula for efficiency of a Carnot cycle. Now, after studying the efficiency of Carnot cycle, we will be moving into the limitations of Carnot cycle. Number 1, since it have isothermal processes, but constant temperature heat addition is not possible. Practically, constant temperature heat addition or isothermal heat addition is not possible. So, this becomes a limitation of Carnot cycle. Number 2 is, we have seen adiabatic expansion in Carnot cycle, and we have also seen isothermal expansions. The adiabatic expansion are very fast in nature, while the isothermal expansion are very slow. Hence, it disrupts the proper processing of a Carnot cycle. So this becomes a limitation of Carnot cycle. Number 3, back work of Carnot cycle is very high. So it is not at all feasible. And number 4, compressing vapor is easy. Compressing liquid is also easy, but compressing both at a time is not feasible at all practically. Hence, Carnot cycle contains vapor plus liquid at the same time. We will study it in details in our next videos of Rankine cycle. So, because of these 4 limitations and much more, Carnot cycle is not at all feasible for practical industrial use. So that is all about Carnot cycle.